So when we're taking apart our ions, we're going to form silver with a 1+ charge, that's aqueous, and then a nitrate with a 1- charge, that's also aqueous. From the sodium chloride, we're making an Na with a + charge, that's aqueous, and a Cl with a 1- charge, that's also aqueous. The silver chloride is going to stay together. It's not going to form ions because it's not going to be dissolved in water. It won't dissolve in the water, it's going to stay as a solid. And then we're going to form our Na+ from our sodium nitrate, and then our NO3 with a 1- from our sodium nitrate. So then again, that is our total ionic equation. Okay, and when we're ready to write our net ionic equation, we just need to locate our spectator ions. So spectator ions are going to be sodium with a 1+ charge. Okay, it's on both sides of our reaction, hasn't changed. And then the nitrate with a 1- charge. So those are our spectator ions. So then writing our net ionic equation, let's use a different color here. So writing our net ionic equation, we're only going to keep things that were not spectator ions. So we have an Ag with a +1 charge, and we have a Cl with a 1- charge, and then we've got an AgCl solid on the right. Okay, so again, that will be our net ionic equation after writing our total ionic equation. Now, we can do net and total ionic equations with single displacement reactions as well. So let's look at a single displacement reaction. So why don't we do in our single displacement reaction, let's do something like copper to chloride reacting. Oh, no, you know what? Let's not do copper to chloride. Let's change that up and do a different ion. Let's say we do copper to sulfate. And then we're going to add zinc to create our single displacement reaction. So then that single displacement reaction, we know that zinc is more reactive than copper, so it will be able to replace the copper. So we're going to end up with zinc sulfate and copper by itself. Then when we write out our reaction here, we'll end up with CuSO4 reacting with our zinc, making our zinc sulfate, that's ZnSO4, and then our copper. Okay, we still have to look at our solubility here. So our copper 2 sulfate is soluble, so that's going to be aqueous, okay? And then our zinc is going to be solid zinc. Our zinc sulfate is also going to be soluble, and then our copper will be in its solid form as well, okay? So then when we want to take apart our ions, or ionic compounds here, we can say that this is really Cu2+, that's aqueous, and SO4 2-, that's also aqueous. Plus we still have our zinc solid over here. On the right side, we've got a zinc with a 2+ charge, that's aqueous, a sulfate, that's aqueous, and then our solid copper. And so that right there is going to be our total ionic equation. And so we sometimes use the short form for total ionic equation as TI. Right? We need to pick out our spectator ions. So here, looks like the only thing that's spectator is going to be that sulfate. It's the only thing that's the same on both sides. So then we're going to write our net ionic equation. So our copper 2 plus stayed put. So did our zinc solid, our zinc 2 plus, and our copper solid. So now that's our net ionic equation. And so with net ionic equation, we sometimes use the acronym NI to stand for net ionic equation. Okay, so with total ionic equations and net ionic